Okay, third time is the charm. Let's go. Okay, so I'm gonna show you how to add bullet physics to Unreal Engine. Bullet physics is obviously a physics engine um, that allows for determinism inside of your games. So we'll hop straight into it. The very first thing you would want to do is go to the GitHub that I have linked. It's right here. Just go in here. Go down here, click download zip, or if you want, you can also just clone it if you want. I won't be making any changes to this unless absolutely needed, but I wouldn't know what I'm doing anyway. So yeah, just click that download zip. I'm doing this live just so other people can follow along. And the project that I have up and running is a blueprint project, and we'll add C++ to it. So yeah. So I'll go here, open this up. We'll have our bullet physics dash main. Go ahead and extract all. We're going to go browse, and we're going to, you want to find your engine, right? So where is it? Reference. And you would need to create a plugins folder if you don't already have one. If you have one, just put it in your plugins folder. So we just go to plugins and select folder, and we're going to do that. And if you have your project open, go ahead and close it. I should have mentioned that beforehand, but I just wanted to show that this was a blueprint project. It started out as a blueprint project, and we'll, add everything in that we need. So here we go. We're going to go back to our directory right here, and if you have a blueprint project, you won't have like any of these binaries, intermediate platforms, any of that. You won't have any of this. Just go to your U project and generate your project files. This is for C++. If you did this through Blueprint, all you have to do is just restart your editor. Make sure when you added your plugin folder that you close it down and open it back up. And for Blueprint users, that's it until we open the editor again, so just sit tight. And for those using C++, which I assume is the majority, go ahead, open up your solution file after you have generated your project files again. And as you can see over here on the right, you should see your plugins folder, and you should see Bullet Physics plugin dash main. You can rename it to just Bullet Physics plugin. You don't need the dash main. Go ahead, yeah, you can rename it or don't. It doesn't matter. And once this finishes doing its thing, you want to hit Control F5 and build. And this will take a second to build. And then you see build one succeeded, and my editor is opening up right now. It's on my, so you can't see it, but yeah, it is opening up. All right, so now we have our editor open, and if you're with, if you had a blueprint project and you're following along, this is where we would begin again. So first off, we want to search Bullet and make sure that BulletPhysicsEngine is ticked to make sure you have a check. Restart your engine if you need to restart it, and yeah. So for clarity's sake, we're going to, well, I'm going to add a folder called physics, and this is where we'll put everything at. But in your content browser settings, make sure you show C++ classes and show plugin content. So inside your plugins, you're going to go to Bullet Physics, the C++. go inside all these folders, and you should see test actor. I don't think you need the bullet content actually. We won't show. No, I lied. You need it. Okay. Obviously, you can see I'm a pro at this. Anyway, you'll see this text actor right here. That is just sitting here. What we're gonna do, we're gonna create a blueprint class. Hold on. First off, if you're running blueprints and you don't have a Visual Studio, just go to Tools, create C++ class. I'll do it here just as, whatever. Call it my class. Click reload all and let it do that. My cat is loud. Don't mind him. So you would let your engine build, or hot reload in this case, and we're gonna reload all. Gonna ignore all this. Okay. I have 2 instances of that up. I don't know why. Oh, probably because I didn't close it. But so here you are. You'd have this, and then you have access to all this, and then for Blueprint, I would assume that you would have to shut down your editor and Control F5 and build it again, and then wait for it to pop up. But if you're following along C++, we're skipping on that. We already did that because we're smart. All right, now, anywho, now that you can go in here and check it out, we're going to right-click and create a blueprint class, and we're going to call this BP underscore bullet world. We're going to set this in the physics. Okay. So inside of here, we don't need to touch anything. We just go directly to the event graph, and we'll start here. So for everything that you want in your deterministic physics world, you will need a delay node. I don't know why this is. I just know this is the way to set it up. So we'll do it like this. And almost forgot. We're going to add a custom event. And we're going to call this run simulation. That's cool. And so off of tick, we're going to get a gate. And tick should go into the enter, and run simulation should go into open. And out of your exit, we're going to call step physics. This is a function in C++ that essentially just allows us to, step into our physics, and it will control it from there. It will control our simulation basically through Bullet. Now, substeps. If you do decide to use substeps, well, you have to, but it's best to keep this number low. I won't change it right now for the sake of, it's just not needed right now. But yeah, that's something that you want to do. And then off of our delay node, we're going to call our run simulation function. Boopity boop boop. And whatever duration you do set for this delay, I prefer 0, but you can set like 0.1, 0.2, something small. Whatever duration you put here, put it for everything after this that you want in your physics world. So everything that you want Bullet to control or to be deterministic, you would add this delay node. That's something we're going to do right now. So we're going to go in here, we're going to add not a level, don't know why I did that. And we're going to add a blueprint, which is an actor, and we're going to call this BP underscore static. So we'll create another one, and we'll also call this dynamic. Okay. I shouldn't have to say this, but just in case if you don't know, static actors are, actors or objects in the world that will not move, will not be movable, that just won't move. I shouldn't have to say that, but just in case you didn't know, something that doesn't move in the world. Anything dynamic is anything that moves, anything that goes in and out, or anything that has simulation within the world. I shouldn't say simulation, but anything that moves just inside the world. Anything that can change in the world, change location, rotation, any of that. If it doesn't move at all, it's static. If it does move even a little bit, it's dynamic. All right, so we'll start with static. And inside of our static, what we want to do for the sake of this demonstration, we're going to add a plane. And I'm going to call this floor. Something that you do not want to do, I'm going to go ahead and tell you, is do not repaint floor to default scene root. This is only for static active. You want to keep the scene root as as the parent of everything that you put in here. So never, never, ever change this. Never. Okay. All right. Because I know I was messing around and I did it because I usually don't like looking at it, but I have to add it. And so it's easier to see. We're going to add a grid material. And we'll make this 15 scaled just so we can see. Come on, save. Then here we go. All right, so the first thing that we want to do, very first thing that we want to do, is create a variable that is a reference to our BP bullet world object. And then we will name this world. All right. Now that we got that out the way, we're going to pull off of here. And again, you will need a delay node for everything that you want Bullet to work in, or anything that you want Bullet to control. Then off of our completed node, we're going to get all actors of class. What are we going to get? We're going to get our BP Bullet World. All right. And from out actors, we're just going to get a copy. And then from there, we're going to drag and set our bullet world. So what we're doing, we're just we get all actors of class of bullet world, and anything that is out here in the world, in our world. If there is a bullet world out there in our map, then it will be added to here, and it will be our bullet world, and where we run our simulation. You only need one bullet world per level. Unless you have like a specific use case, then you can add more. I don't know if that's feasible though. I'm not gonna lie to you. So from our world, we're going to add static body. Of a player, we're going to get a reference to self. And then friction and restitution, we are going to promote to variables. And we would want to make these public because we want to change these. And I will show you what these do later on, but just know that you could make them public. You don't have to, but I would do it. And then off of ID, we would promote this to a variable and just leave it as ID. And we would compile and save. And this does it for our static. So all your static actors inside your scene will look just like this. So now we're going to open up BP Dynamic. Oh, before I forget, I almost forgot. For your mesh, for your floor, what you would want to do is search for physics and make sure simulate physics is set off. Everything. We don't want Unreal messing with physics at all. Like not even in the slightest bit. It should be enough to have simulate physics unchecked, but you never know. You never know. So uncheck absolutely everything, and you should be okay. And we will do the same thing inside of the mesh for our dynamic. So for here, we're going to search for a cone, just so I can demonstrate how this works. And again, we're going to search for physics. Go to our physics tab and uncheck everything. All right. Compile and save. And we're going to rotate this 180 degrees like this and give it a material. And we'll give it gray. All right, so inside of our event graph, if you remember, that's right, we need a delay. Set it to the same that we had inside of our bullet world, and it should be consistent among all three of these. Then we're going to get all actors of class once again, and we're going to search for our bullet world. Then we're going to get a copy. Almost forgot. Remember to create another variable, object reference to BP bullet world. We're going to name it world. We're going to drag out of here and set it. And then out from world this time, we're going to add a rigid body. And this is a function inside of Bullet that essentially take cares of having rigid bodies. What Bullet does, I should have explained this before, but how Bullet is set up right now, or at least how you download it, it's that it uses Unreal's collision shapes, but Bullet handles physics. If you really want it to, Bullet provides like the source code for, where this plugin provides, source code to the Bullet SDK to where you can handle collision on your own, and you want to use, collisions 100% inside of Bullet and not use Unreal at all. If that's what you want to do, you can. But I guess it just depends on your use case. But you can experiment with it and find out what works with you. All right, and out of body, we're going to get another reference to self. And for these floats down here, we're just going to promote these two variables. All right. And so mass, hold on, let me compile and save. All right, mass, how Bullet works is anything above 0, it will be simulated inside the world. Well, everything gets simulated, but you need a mass of 1 to tell it, hey, use gravity. So it just needs a weight, just so it can move. All it has to be is more than 0. You can do 0.1, but it's just best if you just do 1. All right, and then promote the ID once again to a variable. And you should be good to go. All right. Now, we're going to, for the sake of demonstration, we're going to create a new world. And from here, we're going to add our static world, and we're going to zero it out, and we're going to play. All right, so first thing that you want to drag out, really this should have been the first thing we drag out, is our bullet world. Yeah, like I said, you need one of these per world, or well, per world that you want to simulate your physics in. So you need this. And then let's bring in our dynamic actors. Actually, no, just so you can see better, we'll have this here. Clone it and have this here. And because these are in my way, I'm going to move these up and away, out of my face. All right. And then we're gonna add another cone because why not? And we're going to rotate it, and we're gonna unroll all the time, and I still can't get this right. Don't know why. All right. And you'll see this. So for this demonstration, we are going to have this simulate physics, and just so math is somewhat consistent, even though it's not taken into consideration, make sure you have gravity enabled and simulate physics. Just for the sake of this, you don't have to do it, but I'm doing it. All right. And before we go and do anything, before we simulate, inside of our bullet world, we need to tell it what is inside of our world. So what we do, we would add our actors. We have static actors and dynamic actors. Like I said, there's only two types inside our bullet world, and our static actor is in this case, our floor. So this is our static actor, goes in static, and for our dynamic, we'll select that one and we'll select this one. All right. And I believe I'm gonna move these up some. I believe this is all that we need. All right, so now hopefully you can see there's variation in how these things fall, right? Sometimes this will get stuck and fall this way, or sometimes it will do its thing and do like this. So you're like, why isn't it deterministic? Like, what's going on? Well, like I said, this function, step physics, is determined by frame rate. Uh, Obviously, because even takes into account frame rate, and we need a consistent frame rate to achieve determinism. So if I show frames, you get like 120 frames, right? And when I hit play, or when I hit simulate, we fluctuate from 60 to 150 to 40, and we'll just keep doing it, right? And that's where the variation comes into play. So we need a consistent frame rate in order for our physics to turn out the same every single time and not do weird stuff like this. So how do we do that? We go to settings, project settings, and at the top we're going to search for frame. We're going to go to general setting, and we're going to check use fixed frame rate. Now for our fighting game, this should already be set to 60 because fighting games, obviously is standard. You need 60 frames per second. But if you were making another game, make sure that you have this checked and set to your desired frame rate or whatever works best for you guys. Each game is different. Every use case is unique. So yeah. So now, whenever we run our simulation, you see we have a solid 60 frames per second, and when we play, we will get a consistent simulation. Our simulation will never vary, and it will always be the same. And it is hence deterministic. So, say that you want to change certain things, right? Maybe this looks a little clunky, or I don't know, you just don't like the way that your physics are working. Well, in this case, we would need to change how our dynamic actors are colliding with our floor right here. So with our floor selected, we would go here and change settings here. Everyone is different, but I'm going to set mine to 0.8 and 0.3, and hopefully I should get different things. Just play around with this, and your physics will change depending on your settings here. So yes, you can change how physics are calculated, of course, here every single time, but it will be deterministic. You will get change and it'll be deterministic. So I'll just do like 0.1 and 0.9, right? Change will probably be very small. Yeah, but yeah, this one's doing a little tumble like that. This will just go flat like that. So yeah, that is how you basically set up physics inside of here, inside of Unreal Engine, using Bullet. Like I said, you can extend this and not use Unreal's collision system at all, but use everything in the Bullet plugin. And yeah, so that is all you need to know. That is all I have for you. I'll link the Bullet SDK in the description, and you guys can go and have fun with it. So peace out.